Chapter 9 is called Discrete Math. When I was in high school, I took this class called Discrete Math, and I couldn't even really tell you what I did in that class. Some probability, some weird formula stuff. I don't know. I not a, wasn't my favorite. But this chapter, today we're going to be talking about combinations and permutations, which I know you did in Algebra 2, some formulas for that, and that's going to lead us into probability. We're going to talk about the binomial theorem, which I don't remember if you did that in Algebra 2 last year or not, but it's kind of cool. And then we're going to end with, in the chapter, talking about sequences and series, which are just patterns, but how can we make it mathematical is we make you write the formula for the pattern and predict like the 87th term without actually having to write them all out. And the very last section of this chapter is called proof by induction, which is so exciting that we get to do proof, a new kind of proof that you all will hate. And that's where we end the semester, with something you hate. So. Your hope is we run out of time and I don't get to that section, right? That's the hope, but that's why I'm go. All right, this is just basic stuff to get to probability. So it says the fundamental counting principle. I feel like when I took the SAT, the fundamental counting principle was on the SAT because they gave questions like, if I had 5 shirts and 7 pair of pants and 3 pair of shoes, how many outfits could I make? And the old, like in elementary school, like you would make that little tree, you know, like, and you'd be like, oh, 5 shirts, and then each one I have so many pairs of pants. I don't even know what that's called. But the short way is if you have 2 events that can happen in so many ways, in 1 ways and in 2 ways, the number of ways that you could figure out how many options do I have for my outfit, how many ways can I make a sandwich, is you just multiply them together. M1 times M2. You ever watch a Subway commercial or a Pizza Hut commercial and they say, there are this many thousands of ways you can order a sandwich? It's because they take all the options. How many bread choices are there? How many cheese choices are there? How many options for the meat? How many options for the topping? And you multiply all those together, and that's how you get how many different sandwiches you can make. Fundamental counting principle. So your homework today is just a bunch of mixed up stuff asking you to find how many possible ways you can do it. So how many, look at it, isn't this weird that it like changed my font? Isn't that weird? It like squished it in. I didn't do it, it just did it on its own. How many different license plates are possible if each license plate has 3 letters followed by 2 digits? When you do a problem like this, I think it's helpful to write in the number of options that you have, right? Like put a blank. A license plate has 3 letters, like put 3 blanks for that, and 2 digits. And if I can just figure out how many options are for each blank, the fundamental counting principle says I'm just going to multiply all those together. So 3 letters, how many letters are there to choose from? 26, right? How many letters are there in the alphabet? 26, right?
It says 3.
No, but how many letters could you put in there? A through Z, there are 26 of them. So I could say I could choose 26 letters. Can the next blank also be 26? It doesn't say anything about the letters can't repeat themselves, right? If they don't want you to repeat the letters, they'll tell you, but it doesn't say. So I'm going to say I could also put 26 letters here, and I could also put 26 letters here. So 26 letters in the alphabet, in case you didn't know. Also, digits. How many possible digits could I put in there?
99.
This is just a single digit, right? I could put 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Do you agree there are 10 single digits that I have to choose from? A lot of times people forget about 0, right? Remember that we are base 10 number system because we have 10 digits. That's why. So there are 10 digits. And again, it doesn't say it can't repeat, so I can say times 10 times 10. And this is going to be a pretty big number, but you're just going to multiply all this together. I agree. Fundamental counting principle. Then someone could argue, what about the special license plates, right? Well, we're only considering these license plates. Moving on. We have things called permutations and combinations. I'm going to throw you a calculator in a minute if you don't have one, because you need to learn how to use the button on your calculator. But if you are arranging items in order, order matters is what you do to make sure you remember on this. So my favorite permutation to think of is like first, second, third place in a race. It's different if I get first place and you get second place than if you get first place and I get second place, right? Like it switches around the options if order matters. Who comes in first, who comes in second. So another example of that is how many ways can 5 people line up? Well, it matters like where they're lined up. And so I'm going to show you 2 ways you can do this. One way is we could make our 5 blanks, right? And in elementary school especially, you always like to be the line leader, right? If I say how many different people can go in the first spot, what would you say? 5. But once one person's lined up in the first spot, how many are left to go in the second spot? And then when you get down to the end, there's only one person left that has to go there. It is the exclamation. Right, there are in exclamation mark, which is not like super excited in. It means in factorial. That's what you read, in factorial. And that's exactly what in factorial is you take the number and you multiply all the way down by 1. So this is the same as saying 5 factorial. Who needs a calculator? On my calculators, there's a little probability button right next to the PRB, and the factorial button is underneath there. 5 factorial is not a big deal. You can just type in 5 times 4 times 3 times 2 times 1. But like 20 factorial, right, that's a lot of numbers to type in. So if you hit that, you can go over to the third one, it's just a little exclamation mark, and it will give you 5 factorial, which is 120. Have my little binder here. Oh, goodness. If you have 6 books with room for only 3 on a shelf, how many ways are possible? So people like the factorial button, but be careful because you can't always go all the way down to 1, and this is an example of that. If I have 6 books, but I only have room for 3 on the shelf, that means I only have 3 spots to fill in, right? So this would not be 6 factorial because there would be 6 books in the first spot, and then I'd have 5, and then I'd have 4, and I don't have room for any more. And so just be cautious about that factorial button, because sometimes people use it and it's not supposed to be used. And I think you get 120. You can also do a permutation on this, and maybe you remember this from Algebra 2 last year. Is one of the last things you do in Algebra 2, I think. Did you do probability in Algebra 2 last year? Yes. If you want to say how many ways can I order 3 books from 6 books, you can do a permutation. And there's a lovely formula for it, and there's also a lovely button on your calculator to do it. The old way to write this is this. How does it look on your calculator? I always forget. Yeah. So this is like in items taken R at a time. So if we were doing this last one, we would say 6 books, but we're only taking 3 of them. So the bigger number is always the n value. Sometimes they also write it like this, like P parenthesis n comma R, right? Those mean the same thing. It just means a permutation. What? I gotta look my formula up because I'm afraid I don't have it memorized. It'd be bad to give you the wrong formula, right? Oh yeah, thanks. N factorial over n minus R factorial. Most of the time, I'm going to let you use that button on your calculator, but I think there's 2 on your homework that just say find NPR instead of like a story problem. That I want you to actually show me that you could do the formula. You could check on your calculator. But if we just did the one up there, if we did 6 books, but we're only choosing 3, we could say that's 6 factorial over 6 minus 3 factorial. Why is it important to kind of know the formula? Sometimes your calculator cannot handle the number because factorials get really big. Like if I try to do 100 factorial on my calculator, it says overflow error because it's such a big number that it can't do that computation. It's too big. So sometimes you need to know the formula because if you were going to take 100 items, order, and only choose 98 of them or something, then you could do that with the formula, not with your calculator. Because you can cross some stuff out here, right? So just to show you, if you weren't using your calculator, I could say I know that that is 6 times 5 times 4 times 3 times 2 times 1. And 6 minus 3 is just 3, right? 3 times 2 times 1. So look what happens. You can cross out the ones that are the same. So if you had a really big number, you could cross a bunch of stuff out, and then you could get the answer without your calculator. Does that make sense? So people always say, why do I need to know the formula? If you had really big numbers, you need to know the formula. And you do get the same answer, and your calculator will just give you the same answer. We'll practice in a minute using your calculator. You just hit that button, I think. Or no, I don't know else I did this. I think you have to hit 6, and then you go hit that button under probability, which is the NPR button. R. And then you would hit 3. So that has to be in the middle. So you have to hit 6 first, then go to probability, and it's the first one, NPR, and then you hit 3, and it gives you 120. And definitely on the story problems, you're always welcome to use that button. On the test, I believe there's like 2 problems that I say, show me the formula. You can still type it in your calculator, but I just want to see that you are aware of it. Okay? Oh, look, we could have done this one. Oh, we already did it, right? This is the one we could practice with our calculator. So I'm just going to hit on my calculator 7, NPR, I'm choosing 5, and I get 2,520. Did everybody get that number with their calculator or with the formula? All right, moving on. So now there's another formula that is called distinguishable permutations. And the best example that I have of that is if you wanted to know how many ways you could rearrange the letters in a word. The annoying part is it doesn't always make words, but just how many ways could you rearrange the letters in a word? What would the possible number of ways that could be? Well, the key idea here is distinguishable. If you have 2 letters that repeat themselves, if you interchange an N with an N, that's not distinguishable. Like, I don't know that I changed those because it looks exactly the same. So if they ever ask you a question, just like this is the only time a question they ever ask you that you use this formula on, how many ways can you rearrange the letters in Indiana? You have to know that that's a different formula. That formula is not in your calculator. You have to know that you're going to take the number of letters. So we're going to write this out on here. So in factorial, this means the number of letters in the word. And you have to divide by any letters that repeat themselves, all right? You could divide by letters that don't repeat themselves, which means, like, if it doesn't repeat itself, it only shows up 1 time. What's 1 factorial going to be? 1, so we don't need to divide by that. So we're going to divide by each letter, the number of times it is repeated. That's what that means in 1, and 2, and 3, in sub k. If no letters are repeated, then it's just in factorial. How many ways can you rearrange a word that doesn't have any letter to repeat itself? It's just the number of letters factorial because you could just rearrange them all. But they're going to give you ones that repeat themselves. So like Indiana, I'm going to say, step 1, how many letters are in Indiana? So I'm going to say 7 factorial. But I have to divide out any ones that repeat themselves. And since there are 2 I's, if I flip these 2 I's around, it would still spell Indiana. It wouldn't look any different, so that would not be distinguishable. So since there are 2 I's, I'm going to divide by 2 factorial. If it repeated itself 7 times, I would divide 7 factorial, right? How many times it repeats. In. There are 2 n's in Indiana, so I'm going to divide by another 2 factorial. There are also 2 a's in Indiana, so I could divide by 2 factorial again. Notice that there's 1 d. If you want to divide by 1 factorial because there's 1 d, you can. I just never include the ones that only repeat once because dividing by 1 doesn't change anything. And then again, you can use your calculator. Be careful if you try to type this in all at once. If it were me, I would do the top and the bottom separately, or I'm kind of a weirdo and I like to do stuff without a calculator sometimes. 2 times 2 times 2 would just be 8, right? On the bottom. So you could just do the top and then divide by 8, or you could cross out the 4 and the 2. I don't know, we could just get crazy on here, but I'm guessing you're just going to type in your calculator if that's what you always do. I think 7 factorial is 5,040, and then you divide by 8, and you should get that there are 630 different ways that you could rearrange these letters, and it would make a different arrangement. They will not be words, but it would be a different arrangement. Questions about that? That's the one that people tend to forget because they see, they just want to use the permutation button on their calculator, but you can't. All right, really only one other formula, and then we just can practice a few. If order is not important, like if I want to know, like the pizza or Subway one, how many ways could I order a pizza? It doesn't matter if I order sausage, cheese, pepperoni, or pepperoni, cheese, sausage. It's the same pizza. It doesn't matter in what order I pick those. And so if order does not matter, that is called a combination, which is the other button on your calculator. So we need to make sure you know that that means order does not matter. Because order doesn't matter, you have to divide by something extra. So again, NCR is how it looks on here, or sometimes it's C, parenthesis, N, comma, R. N is the total number of objects. How many taken at a time is R? N is always the bigger number. We're going to take N factorial divided by R factorial, and then again N minus R factorial. GD over there.
I really about to like, why are you so paranoid about I was really worried when I saw this, like, wow, you're not calculating it. And I was like, hey, I just get a calculator. And I was like,
They've all taken it. Why are they all cheating?
what? Copyright said.
Why did I write this?
Yes.
It's just another way to write this. Like both of these could equal this. Does that make sense? Like you don't have to write this. But sometimes in the book they write it that way, and I just want you to know it means the same thing.
Okay.
Notice because order doesn't matter, we're going to get smaller numbers with combinations because we're dividing by more stuff. Because in a permutation you get to count 1, 2, 3 is different than 3, 2, 1, but in a combination that's the same answer. So again, 2 ways I kind of want you to do this. On the homework, there's a couple questions listed like number 6 that I want you to show me the formula, type it in, see how you can cancel stuff out. And then if it's a story problem, then you can just use your handy-dandy calculator. So on this one, I would say that's the same as saying 10 factorial over 6 factorial, and then 10 minus 6, I'm just going to say is 4 factorial, if you're okay with that. And again, the point of the formula is if you had really big numbers, we can cross stuff out here, and maybe not even need a calculator at all. And I think if you had 100 factorial, you probably wouldn't want to write all that out. But for me, if I do 10 times 9 times 8 times 7 times 6 factorial, do you agree that that's what would be left? 6 times 5 times 4 times 3 times 1. Why am I stopping at 6? Because I have a 6 factorial on the bottom. So I know all of that 6, 5, 4, 3, 2, 1 would cancel out. This, I have 4 times 3 times 2 times 1. Could I cancel some of this out with some of this up here? It's multiplication, I could. If I didn't have a calculator, I think I would want to. Like, could I say 4 times 2 is 8, would cancel out that 8? You see what I'm saying? And 3 divides into 9 3 times. You don't have to do it. I'm letting you have a calculator, but I just wanted you to think if you didn't have a calculator, I could do this now without a calculator very easily. 7 times 3 is 21. 21 times 10 is 210. And obviously, I know it's much easier to type that in your calculator, and you're going to type it in your calculator. But I believe there's one somewhere that they have to, that's like really big numbers, you can do it. So what about number 7? Do you agree that that means order doesn't matter? If 12 pizza toppings on a list, how many ways can you choose 2 pizza toppings? Order doesn't matter. So you have to recognize that. And so now, if you recognize it's a combination, now you can just say 12 choose 2, and you can type it in the calculator. That's the hard part, is knowing what it's a combination. What'd you get? Did you do this yet? Is that right? 66? Well, shoes is the second one. 266. Ah, so nice. Is there more? Is that it? There's a big mix of problems on here, and tomorrow I will go through a few of these with you. But there's a lot of different stuff. Some of them only say, is it a combination or a permutation? They don't even make you work it out. Some of them are not combinations and permutations. Some of them are just the fundamental counting principle, right? Multiply, how many options together? So don't overthink those. A lot of the ones with like the license plates and stuff, draw the lines like I did. Like it's still how I do those problems. Notice 15 and 18, the directions say without a calculator, and I wrote that up there to remind you. Use the formula for the combinations, permutations on those. You can check with your calculator, but I want to see the work on those. But then 19 through 22 just says, is it a combination or a permutation? You don't actually have to find it, so don't do extra work on those. You just have to say, does order matter? Permutation. Does order not matter? Combination. And then the rest of those are just a bunch of different problems. Tomorrow we'll go through these, some questions on these, and I will pass back the tests, and we'll do test corrections tomorrow. So the nice thing is you won't have new homework for tomorrow, but you will have test corrections to work on if you don't get them finished in class. And then I'll probably give you all of the next week to retake that test. Okay? Great. Can I help you with logarithms?